Hello, and welcome to 10.2 of Calculus Online. I hope all of you are doing well. 10.2 is very similar to 10.1 as it's a differential equation. The difference here is considered a first-order differential equation, which means we need an integrating factor. I will show you in the second part how to find the integrating factor. The first part, we're just going to go over what the form looks like and how you actually run do the problem. So when you're looking at a differential equation of first degree, you have to have the form dy dx plus p of xy plus or equals q of x. Now, the dy dx is your differential. The px times y, so you have a function times y, is equal to a different function. Now let's go on to our equation here. So when you first look at our equation that we are starting with here, you notice that x is in the way. So the first thing you must do is divide everybody by x to get the dy dx, or the differential, alone. Once the differential is alone, now you have to have the form pxy equals qx. So when we have 6x over y, our p of x is the 6 of x, and the y is just the y. We subtract the 2x cubed over, giving us our q of x, or negative 2x cubed. Our integrating factor here is x to the 6th, which I will show you how to find here in a little bit. But right now, this is what helps us get our derivatives. When we multiply each term by an integrating factor. So every term is multiplied by x to the 6th, giving us x to the 6th dy dx, 6 times x to the 5th y, minus the 2x to the 9th. When you look at this here, the left side of your equation now becomes your derivative. So when you look at the left side, we now have the derivative of x is x to the 6th y. So we're going to replace the left side with our derivative and leave the right side alone. So our derivative is dx x to the 6y equals negative 2x9. Next, we must take the integral of both sides of the equation. When we integrate both sides of the equation, we get x to the 6y on the left. Now we have to integrate or take the antiderivative of negative 2x to the 9th. So when we take the antiderivative of negative 2x to the 9th, we have x to the 10th over the 10th, and we just reduce. Our equation is almost complete here, except y must be by itself. In order to get y by itself, you divide by x to the 6th. After we've done this, then we will learn how to calculate c. So let's continue on and show you your steps. Okay, your integrating factor is always found by taking e to the antiderivative of p to the x, right here. So when you do that, you're going to take every term, the dy dx, the pxy, and the qx, times that integrating factor. So we have our form of our line. We calculate our integrating factor. We multiply every term by the integrating factor. This will give us that the left side is the derivative of the integrating factor times y. You integrate both sides, and then you solve for y. Let's try our equation. Our equation is dy over dx plus 2xy minus x e to the negative x squared equals 0. We're going to find c when y of 0 equals 3. When you look at this, you notice that the dy dx is already alone, so we don't need to divide. The only thing we need to do is to move this term to the other side, because that's our q of x, so we add it to the other side. Your second step is to calculate your integrating factor. Integrating factor in this case is e to the antiderivative 2x dx, which is just e to the x squared. After you've calculated that, you multiply every term from above by ex squared. So once you've done that, now the left side of your equation is going to be your derivative. You do not need to actually do this part right here. That was just to help you understand. So that's your derivative. So we have the derivative of our integrating factor, e to the x squared times y. Now we have the second side, or the right side of our equation. We simplify this. We know that e to the x squared times e to the negative x squared is just 1. So that is canceling out, giving us x. Once we have simplified our equation, you take the integral of both sides. Okay, when you take the integral to the first side, you get e to the xy, or your integrating factor times y. Now you have to take the antiderivative of the x, which is x squared plus c. So currently, we have e to the x squared y equals x squared over 2 plus c. Now you must solve for y, and you do that by dividing by e to the x squared. So you're dividing all three terms here. After you have solved for y, now we use the information that we were given above. The y of 0 equals 3. We let y equal 3, and we plug in 0 for all the x's. Well, 0 squared is 0, so that term cancels out. And anything to the 0 power is 1. So we have c equals 3. We replace the c up here in the original equation with its value to have the equation when at x0 and y is 3. Okay, it's your turn now. So pause the video, try it on your thing, and then check to see how you have done. All right, your equation was 2 dy dx minus 6y minus ex equals 0 at y0 equals 5. First step, divide everybody by 2. Sorry about my writing. I am starting to learn how to write with this, and it's not very good yet, but we will get better. So you divide everybody by 2. This is supposed to say dy over dx minus 3y minus e to the x over 2 equals 0. Once you've done that, you take the negative e to the x over 2 and you move it to the other side. So this guy's been moved over. Now we have to calculate my integrating factor. So over here is where we've calculated our integrating factor. So we took e to the integral of negative 3, since there was no x, dx, which is just e to the negative 3x. So e to the negative 3x is our integrating factor. You multiply every term by e to the negative 3x. Once you've done that, you know your left side is your derivative of x, e to the negative 3x, your integrating factor times y, equals, when you simplify e to the negative 3x x, you get e to the negative 2x over 2. You take the integral of both sides for your antiderivatives. When you do that, you will get e to the negative 3xy equals e to the negative 2x over negative 4 plus c. Don't forget your c. You must solve for y, so everybody gets divided by e to the negative 3x, giving you y equals e to the negative 2x over 4 e to the negative 3x plus c over e to the negative 3x. Simplifying your equation, so you know you subtract exponents here, we get minus e to the x, oh, I forgot my negative sign up here, I lost it, minus e to the x over 4 plus c e to the 3x. We have to evaluate this at y sub 0 equals 5. So we plug in our zeros and our 5s, giving us 5 equals 1/4 plus c. We add the 1/4 over, so c is 21/4. We replace our original up here with c equals 21/4. And your final equation is e equals negative, or y equals negative e to the x over 4 plus 21 e to the 3x over 4.